All right, Algebra 2B. Here we are with a worksheet day today. And I am going to work through just a couple with you here. Just a couple. Just to get you going here on the right foot. If you need it. If you don't need it, more power to you. Keep on going. Okay? A lot of people say that 1 and 2 are usually easier. And that 3 and 4, as you get going down the line, get a little bit more challenging. So I'll do one of the more challenging ones with you here. Okay, we're in 180 to 270. That's quadrant 3. And our sine is negative 2/3. All right, so if we're in quadrant 3, sine is negative 2. Hypotenuse was 3. Opposite over hypotenuse, negative 2/3. Hypotenuse is always positive. Okay, little a squared plus b squared equals c squared. We're going to get radical 5 over here. And it's negative because we're in quadrant 3 where sine and cosine are both negative. Okay, so we're going to put that down over here off to the side that cosine theta is also negative radical 5 over 3. Okay, so for you, I only want you doing 2 of them on each one, right? So double angles here, half angles there, double angles here, half angles there. I don't care which way you go. The answer key has all 4 down, but I just want you to do 2 on each one. Double angles, half angles, double angles, half angles, alternate however you want. But I'm going to go through all 4 for this one. Okay, so our double angles, sine 2 theta, is 2 times the sine times the cosine. 2 times the sine value of theta times the cosine value of theta. So we got negative 4 and then a negative there makes this a positive 4 radical 5 over 3 times 3 is 9. Okay? Let's do our cosine. Cosine double angle, you got options. I like the first one, cosine squared minus sine squared. So cosine value, that's a negative radical 5, squared minus sine squared. Okay, negative radical 5 squared is going to be a positive 5 ninths minus negative 2 squared is 4 ninths equals 1 ninth. Okay, half angle. Let's see if I can squeeze this in. Half angle for sine. Okay, if I cut these in half, that's going to put me at 90 to 135. That would put me in quadrant 2 now. Okay, and in quadrant 2, sine would be positive, but my cosine half angle would be negative. Okay, so keep that in mind. So sine is, a little off kilter here, positive, big square root, 1 minus cosine, which is negative radical 5/3 over 2. Okay. Let's make a little wall this off here. 1 minus negative, so that's going to be a plus on the next line. We got an over 3, so I'm going to make this be 3 over 3 plus radical 5 over 3 over 2. Okay, and that's going to be over 1, 3 together there. And instead of dividing by 2, we're going to multiply by a half on this next one. All right, so we got 3 plus radical 5 over 6. Okay, so you think you're done, but you're not done because we've got to separate top and bottom. So I'm going to keep going. I'm going to spill into this section. We're not going to do, well, you're going to do number 6 on your homework. You might need a separate piece of paper. I am not going to do number 6. I'm going to do number 5 with you, so I'm going to use this space here. Okay, so we have the square root of the top over the square root of the bottom. Okay, we can't finish with the square root of 6 as our denominator. So we're going to take this in. Remember, this is the tricky part, because this is a square root and this is a square root. So I can take this 6 into this, but I can't take it into the second one. So this is going to be the square root of 18 plus 6 radical 5. Okay, it's one square root there, it's one square root here. So this times 6 can get into the first one and go to 18, but it can't get inside the second one and make that 30. It's going to sit outside 6. Okay. Radical 6 times radical 6 is regular 6 on the bottom. And now you're done. All right, that was sine half angle. Cosine half angle is very similar. Remember we said because we're in when we cut our angle in half, we're in quadrant 2, sine is going to be positive because it's up. Cosine is negative because it's back. So this is going to be a negative at the end. Negative 1 plus cosine, and our cosine here was negative radical 5 over 3. Okay, we kind of did almost the identical problem before with the sine half angle one, but it's just going to have a different sign in the middle here. So we're going to have negative 3 minus radical 5 over 3. Because that's a 3 over 3, put them together, over 2. Change this to times by a half. Okay, same situation. Now we're going to do the square root of the top, square root of the bottom. Can't stop at that square root of 6 on the bottom. All right, same thing. This is one square root. This is one square root. So this can get inside to that 3. It can't get inside to the 5, but it can go right in front. Negative in the front of that. 18 minus 6 radical 5 all over regular 6. Okay? So that was the double angle for sine and cosine and the half angle sine and cosine. You can see that takes up a lot of space. You probably would not be able to squeeze all that into each problem. That's why I'm having you alternate. Okay, do the double angle for one problem, do the half angle for the other. Okay, answers for both, for all 4 things, are on each of those problems. Okay, let's come down here and do it says use a half or a double. Okay, you're probably not going to use a double very often. It's probably usually going to be a half. If it was a double angle formula, then anything that you double to get onto something, those would have had to have been normal values anyways. So the only weird ones you're ever going to get are going to be from cutting things in half. Okay, so it's probably going to be a half angle formula. So 105 is half of 210. That's my theta over 2. So 210 is going to be my theta in the formula here. Okay, so just a couple of quick sketches. Where is 105 degrees? 105 degrees is here. So that's going to be in quadrant 2, where cosine is negative and sine is positive, which means that my tangent answer should be negative. A couple other things. Where's 210? That's what we're going to be using. 210 is down here. Okay. Our half angle formula is very dependent on cosine. This is negative radical 3 over 2, comma, negative a half, but we're using the negative radical 3 over 2. Okay. So your formula is, we want negative because we're tangent, we're in here. 105 is going to be negative for tangent, so we want negative, big square root, 1 minus the cosine of the 210 part, negative radical 3 over 2 over 1 plus the cosine of 210 part, negative radical 3 over 2. Okay, so in simplifying this, I'm going to kind of forget about that giant square root for a second. Okay, I want these to be a 2 over 2, 2 over 2, minus the negative is a plus. So we're going to have 2 plus radical 3 over 2, 2 minus radical 3 over 2, multiply by the reciprocal. Okay, now we're back to normal here. Negative on the outside, big square root. We got 2 plus radical 3 over 2 minus radical 3. Okay. Now, before I split these up, you could probably look to split them up now. Okay, but I want a normal number on the bottom. I can't have these radicals on the bottom. So we do the conjugate, the opposite. So this is 2 minus radical 3, so I'm going to multiply by 2 plus radical 3. The top and bottom. Now that 2 plus radical 3 has nothing to do with the top already being 2 plus radical 3. It was because the bottom was 2 minus radical 3. But it's nice that the top is already 2 plus radical 3, because if I do 2 plus radical 3 times 2 plus radical 3, that's 2 plus radical 3 squared, which is really nice when you're inside of a square root. So this is going to be 2 plus radical 3 squared. Okay, across the bottom, 2 times 2 is 4, plus 2 radical 3, minus 2 radical 3, perfect. Negative radical 3 times positive radical 3 is going to be a minus 3. And 4 minus 3 is 1. So we got 2 plus radical 3 squared, square root, over square root of 1. Don't forget your negative out in front. See, I already lost that. Do that again. Square root of something squared is itself. Square root of 1 is 1. Anything over 1 is just normal, so I don't even need the over 1. Okay, but we had this negative waiting out in front. Take that into both. We have negative 2 minus radical 3, and there it is. Okay, that one worked out well because these ended up being the exact same thing. 2 plus radical 3 times 2 plus radical 3. 2 plus radical 3 quantity squared. Okay, I might have missed that on the, if we did that on the notes yesterday, something like that. I don't remember if that happened, if I multiplied that out, or if that situation came up. But if that matched up yesterday, we should have gone with parentheses squared instead of multiplying it out. If that doesn't match up perfect like that, then go ahead and multiply that out. But if they match up, 2 plus radical 3, 2 plus radical 3, that's 2 plus radical 3 squared, which is really nice inside of a square root, because square and square root cancel out, and there we go. Okay, what are we at? 13, 14 minutes. We got time for one more with you. Okay, I'm going to do the first one this time. You can do the sine one. Cosine of 67.5. Again, anything where you're going to have a weird one that you just can't look at on the unit circle, it's probably going to be a half angle formula. So 67.5 is half of 135. So 135 is my new theta in the half angle formula. Let's think about where things are. My 67.5 is in quadrant 1, so I'm expecting a positive answer. 135, what I'm going to be using for my theta over 2, what I'm going to be using for this theta, when I'm doing my actual work here, is right here. My cosine of that is negative radical 2 over 2, comma positive radical 2 over 2. But cosine's the first one, negative radical 2 over 2. Okay, cosine half angle formula. We said it's going to be in quadrant 1, so we're expecting positive. Big square root. 1 plus the cosine value, negative radical 2 over 2, all over 2. Okay, we know what to do. Make this 2's. 2 over 2 minus radical 2 over 2. It was plus a negative, so I call that minus. So we got 2 minus radical 2 over 2. Instead of dividing by 2, we're going to multiply by a half. Over 4. Now when I split these up into separate square roots, square root of the top, square root of the bottom, square root of 4 is a nice 2. Can't do anything with that top, so it stays. And we said we wanted it positive. 2 minus radical 2 all over regular 2 now on the bottom. Whew, there you go. We're not going to do the identities because the proof is the work and the work is the proof. That's all you. Look back there at your formula sheet and see if you can make it there. Okay? If you can't, if it's not the most, if yours doesn't match the answer key, that's okay. What I consider the most efficient and quickest way to get there, that's okay. There's more than one way to get there, just as long as it's all mathematically accurate. If you want to give the story problem a go, you can. I wrote skip on it on the answer key. So there you go. All right, you got the rest of the class to work on that. And we'll talk about that tomorrow when we start reviewing for the quiz.